And welcome everybody to the Daily Space Weather. And we're looking at the sun here, a bunch of things going on. Some ejecta leaving the solar corona, we'll show you momentarily. We're looking at the Solar Dynamics Observatory view of the closest star here, El Sol. 193 angstroms is one of the ionized spectral states of very, very hot iron. And we've got some coronal holes here. One down here that kind of filled back in. A couple new sunspot groups, 2827 and 2828. A possible additional sunspot also. We'll be talking about solar cycle progression. First, the solar intensitygram. You can see the spreading out of these umbrae here on sunspot 2827. 2828 has been much more stable. In fact, it looks like it's largely degraded here. But 2827 still harbors the type of field complexity required for producing some solar flares. Here's a close-up of the field scenario. And there was some umbra up here also. So also in the northwestern portion, we did see some tiny umbrae while we did show prep. Anyway, that's the colorized magnetogram. Next, the view from Lagrangian point 5. So first, I would direct your attention over here on the left pane to stereo A. You can see this large plasma plume here. This is sort of in the southern region here, and you can see it's in the southwest, as you can see it from Lagrangian point 1 also. The right pane here is the LASCO SOHO C2, located directly in between Earth and Sun. The left pane is stereo A, located out here at Lagrange point 5. So this ejecta here is in the process of ejecting, and it's taking its good old time. There is also some additional solar coronal material on the way to Earth. NOAA is forecasting that to arrive on late June 1st, I believe. We'll get to that momentarily. First, a diagram of the solar system. Here's where stuff is now. And there's where things will be in 1 week, approaching another new moon. And I would remind you, if you haven't seen our smAsho.org Presents the Sun series, the latest one, part 16, is quite spectacular. Check it out. Here's a clip. Here's a little teaser from the end of the video. Cast this onto the largest screen that you've got, as it is absolutely spectacular. And there's a whole playlist there. You can find all of our playlists at youtube.com/smashomash/playlists. smAshomash.org Presents the Sun Part 16. Check it out and put it on a big screen, folks. It's, again, quite spectacular, including the C9.4 class solar flare event, the coronal mass ejection, which sparked a brief proton event. Here's a star chart. It's in the-sky.org. If you're up before dawn, you may see the moon and Saturn and Jupiter near the ecliptic, rising ahead of the sun. The radio flux in the 200 megahertz variety, the 10.7 centimeter radio flux as it's otherwise known, all the way down to 74 despite some new sunspots growing. So weak solar activity in general. Here's a 1-year chart of the radio flux. It's this black line that's reported from Solon.info. And you can see here late in the day tomorrow into early in the day on June 2nd, NOAA forecasting the arrival of the coronal mass ejection featured in smAshomash.org Presents the Sun Part 16. So some ejecta on the way here. I was forecasting it to arrive a little bit earlier in the day tomorrow. I thought it was a little faster moving than NOAA thought. So we'll have to keep an eye on that. We did see a 6+ magnitude quake here in Alaska. Here's the 90-day global seismicity bar graph from volcanodiscovery.com. We only saw one 5 magnitude and one 6 magnitude quake here over the past 24 hours. And that was in Alaska, likely to be felt by Anchorage. Shout out to our Alaskan viewers, such as Brett. Let us know if you felt that quake, which was epicentered right in the Talkeetna Mountains. The Talkeetna Mountains here, southeast of Denali State Park and northeast of Anchorage. Anyway, that's the location of that. It was a 6.1 magnitude quake at 73 kilometers depth, and it came in at 6:59 Universal Time, so just before we did the show today. That 6.1 magnitude quake in Alaska. There was also a 5.4 magnitude quake south of Japan here at over 500 kilometers depth. Chile saw a deep quake at a 4.3 magnitude over 100 kilometers depth. The Band AC saw a 4.5 at depth. We're just going to allow the list to scroll here. Band AC also saw a 4.4 at over 230 kilometers. Looks like volcanodiscovery.com has been missing some of these quakes here, as we see at least 3 5+ magnitude quakes. This Indonesian quake at a 4.5 magnitude, nearly 200 kilometers. This 5.3 at Tonga, over 160 kilometers depth. Kurile Island saw a nearly 5.0 magnitude quake. New Zealand saw a 5 magnitude quake. Again, there's that 6.1 magnitude near Chickaloon, Alaska. A couple of deep quakes also coming in after that, such as this 3.3 and this 2.6, both south of the 6.1 magnitude quake. Continuing on to check volcanoes. And I think volcanodiscovery.com may be on vacation. In any case, Nyiragongo still on the list. Also, Samisopochnoi in the Aleutian Islands has lowered its volcanic alert level to yellow. It's a great reminder to not pole vault the caldera. Please don't pole vault the caldera. You're not Steve Stimpak. You're not a superhero of caldera pole vaults. This public service message brought to you by smAsho.com. No major solar flares. We saw one nearly reach into the C-class range. Largest flare of the past 24 was this B-class flare. Peak flux happened around 5:40 Universal Time, just a couple hours before we recorded the show. The proton event that we saw here from that coronal mass ejection on the 29th is leaving the graph here. Here's the 3-day chart of proton flux. The proton event has long since subsided. No additional spikes in the proton flux. GOES magnetometer showing pretty tight range here. And we are expecting an acceleration of the arrival of the South Pole-oriented current sheet. We actually forecasted it yesterday, and you can see it now in the top view ecliptic plane field plot. You can see this red area right here. This red South Pole-oriented current sheet making a sudden move, and that's because there's plasma coming out of the corona in between Earth and Sun, and it's accelerating the arrival of the South Pole current sheet. I'll just leave it at that. But this was forecasted, and anyway, we expect to be in the South Pole current sheet later in the day today. So that could actually spark some geomagnetic unrest as we see a new magnetic environment. Next, the line of sight ecliptic plane field plot. And expect to see this blue line here suddenly shift as well We haven't seen that happen yet. Expect to see that shift to the north depending on how strong the south solar polar field is with respect to the Earth. Next, we're going to show you the line of sight coronal hole plot, and then we're going to show you some very interesting correlations between the last solar cycle. So here's where the line of sight coronal hole plot is right now, and it's actually missing a coronal hole right here in the Earth-facing vicinity, as well as a smaller one down here. Not sure why that's missed, but in any case, that's why we showed you the 193 angstroms view to start the video out. And what we're going to show you next is where the solar cycle was 11 years ago. So the solar cycle is about 11 years in length, and we're going to go back in time and show you this same data from 2010. So on these same dates in 2010, here's the solar sunspot number, and you can see we were around there back in 2010. And while we've got more sunspots right now, we're seeing a coronal hole drought. It's a coronal hole drought, folks. There's the radio flux as it was in 2010 versus where it is now. Quite similar in radio flux and sunspot number. And now check out the line of sight coronal hole plot. Look a little differently. You can see trans-equatorial coronal holes, as we talked about yesterday with Eugene. By the way, if you haven't seen that video, we did about a 30-minute video yesterday with Mr. Bagashov of Minsk, Belarus. And you can see how many significant coronal holes we were seeing back in 2010. Again, here's the current situation from May 27th to May 31st in 2021. And here it is on May 27th to May 31st in 2010. Vastly different field progression process, as we are seeing a coronal hole drought indeed. Vast differences between this and the previous cycle. Next, back to current day status. Sunspot 2827 and 2828. We may be seeing a sunspot forming up here. We'll be keeping an eye on that. And when I say eye on, the pun is intentional. Detected filaments. Not really showing the most important one, which is someplace around here, I believe. And we showed that earlier in the video on the LASCO C2 and the Stereo A coronagraph. Global geomagnetism currently at calm conditions. We see a KP of 1, the KP index of measurement of that global geomagnetism. Let's take a look at the real-time solar wind. So here's a real-time solar wind, fairly uneventful here, and expect to see some spikes from the glancing blow expected from the coronal mass ejection we saw on the 29th. Current conditions are about 5 protons per cubic centimeter for the solar wind density. 383 kilometers per second is the solar wind speed. Next, the Geospace Magnetosphere movie showing you magnetohydrodynamic pressure in nanopascals. So it's the space weather modeling framework. It's 4 hours of data, or it should be. And it looks like we've got the full 4 hours here. We'll let this play through. Fairly stable magnetohydrodynamic pressure here over the past 4 hours. We'll also show you ground magnetic perturbations, geospace delta B, changes to the Earth's B field. This one you're actually looking at nanotesla as opposed to nanopascals. And like the last video, this is 4 hours of data. We show it daily since we are currently living through a geomagnetic excursion. And since it refreshed, we'll let it play through to make sure we get the most current data and a full run. And today's cosmology segment will be a completely separate video. Look for that to come out a little later in the day today. And we'll talk about some cosmic ray flux and other interesting cosmology topics. And next we'll move into the realm of electrons. Electrons have the capability to charge up satellites. And we don't see any of that going on right now. There are the CSERT charging hazards. Here's the 1-year chart of the greater than 2 mega electron volt electron flux. That's another Solon.info graph. Solon.info/solar for lots of data. Here's a 3-day chart of that, and we're just in a fairly low range here. Here's the Electron Forecast model. Green boxes are the forecast. Yellow diamonds are the observation. And I would tend to disagree with this uptick here. I think that's going to be a little bit later than what we're seeing. But we'll have to keep an eye on that. And here's a total electron content forecast. So you're looking at the entire air column here, all the way from your GPS satellite down to your handset. This will show you where errors are most likely to occur. It's a full view of the total electron content, the entire air column's electron density. And this is indeed quite accurate. I've corroborated GPS errors myself. We do see some anomalies at nighttime there. Here's a diagram of the Van Allen belts. Feel free to pause the video if you need to look at that longer. Next, we're going to look at the ionosphere. We looked at the full air column. Now we're going to look at one slice in vibrational frequency, the F ionosphere layer at about 300 kilometers of altitude. And we see a highly discharged ionosphere. At the end of the video here, we'll show you. And I'm going to press reload here as it mysteriously stopped running. We're actually looking at the last 2 days here. And there's the latest image. And you can see quite low frequencies here, barely making it to 9 megahertz on the sun-facing portion of the Earth. And this also does give you insight into the season, folks. The sun is going to be someplace around here, and this little blob of high vibrational frequency trails the sun a little bit as the Earth rotates. Today's meteorology segment will actually be a separate video as well. Look for that coming out. If you haven't checked out the meteorology segment, check it out. Again, you can find all of our playlists at youtube.com/smashamash/playlists. And here's our first bonus feature. This is the ground-based solar observatory in Udaipur, India. You can see some of the filaments down here in the southern hemisphere. There are also filaments up here. You can see these little slight darkened regions there. Some of the filaments in the south are protruding off of the edge of the solar disk. And here's the solar intensity gram. It's sunspot 2827, which looks like it's actually degraded since we did show prep here. It is still beta class, though, and still does have the capability to produce some solar flares. This area here might be a sunspot as well. Let's take a look. Could be another sunspot forming there. That would be 2829. And you can barely see a little darkness there. I wouldn't call that a sunspot yet. But 2828 is indeed a sunspot, despite being pretty small. It is beta class. Those are actually separate polarity umbrae there. There is a south and a north pole. So, oh, you know what? I stand corrected. Those are both North Pole umbrae. So these blue spots there, that is the umbra. Next, I'd like to thank our patrons, the true source of funding for the content. If you want all the alerts long before anybody else in the world, help to fund and increase the capabilities of our operation by becoming a patron at patreon.com/smashamash. Thanks again to our patrons. Here come your final bonus features. And we figured we'd close out the video here with some composite imagery. So we've got 211, 304, and 171 angstroms here from the Solar Dynamics Observatory. By the way, the sun is not reversing its rotation there. We've got some out-of-order data. So if you see it looking like it's going back and forth, if you look at the timestamps, you can see the timestamps are going backwards. 1903 and then 1818. The sun is not reversing its rotation, folks. That would be an unfortunate and rather serious event not happening. Anyway, there's a sunspot of the There's a close-up of the equatorial region, including both sunspot groups. Here it is in 171 angstroms and colorized magnetogram. Thanks for tuning in to the Daily Space Weather. I've been your host, Dan, a.k.a. smAsho. By the way, thanks to our military personnel on this Memorial Day. And may that solar wind be at your back.